Okay, we're gonna do a just an example here of determining the density. We're gonna use our sample 1-1 data. So bear with me here with my homemade document camera here, but we're using sample 1-1, and we're looking for the density. And the units we're looking for here is grams per centimeter cubed. And remember that we have a cylinder here, and the volume of a cylinder is equal to pi r, so it's the area pi r squared, which is the area of the top surface times the height. Pi r squared h is the volume of a cylinder. And the density is equal to the mass divided by the volume. And you can go to the units, grams per cubic centimeter for that. And we want our volume to be in cubic centimeters and our mass to be in grams. That would be ideal. We've measured our samples. We've measured the mass on our weigh scale, and we've measured the diameter and the length. So that diameter, we can get the radius, things like that. So on our sample 1-1, we have a mass of 3.893 kilograms. And we measured the diameter, and that was 102.85 millimeters. And just cheating a little bit to get that into centimeters, just simply move the decimal place over 1, 10.285 centimeters. And our length we measured 202 millimeters, which again, cheating a little bit, jumping and converting to centimeters, just thinking ahead a bit that I want grams per cubic centimeter. I can also do the same with the mass here. I want this in grams, simply move the decimal place over 3 places, 3,893 grams. So that's what we need. And now we can just work on our formula. I'm going to work on it a bit. Density is equal to our mass divided by our volume. I'm going to replace the volume with pi r squared h. I can work on this even a little bit more, and that's going to be pi d squared h. And if I change r to d divided by 4, or d divided by 2, it's half of the radius is half of the diameter. When I square that half, I get a quarter, so that makes me put a 4 up on top. So hopefully that didn't confuse people too much, but I'm exchanging, instead of radius squared, I'm using diameter over 2 squared, which it works out, diameter over 2 in brackets squared is diameter squared over 4, and I flip the 4 to the top. So this is getting me into a single formula that I can use, and I have, if I look at what I have my mass, I have my diameter, and I have my length, or my h, so I can calculate my density. So the density here, draw my line, I have 3,893 grams. I have to put the 4 in there, and pi is on the bottom. My diameter squared, so 10.285 centimeters, and that's squared. And my height, which is 20.2 centimeters. And if I look at my units, I have grams, I have centimeters squared, and centimeters, which is centimeters cubed. That gives me the right units, so now all I have to do is multiply all the tops, divide all the bottoms, and when I do that on my calculator, 3,893 times 4 divided by pi, divided by 10.285 squared, and divide it by 20.2, I end up with a number of 2.320, somewhere in that neighborhood, grams per centimeter cubed. And that's the density. And I'll just put a 1-1 there because it's the density of sample 1-1. And just a note, we haven't done any math courses together, but math-based courses. So this is, I always set my stuff up on my line here to make sure my units are all matching up. And as far as rounding off, I could have rounded off these numbers early here and rounded off again, rounded off again. When I multiply a bunch of rounded off numbers together, I'm going to get a really rounded off number and I could get a really inaccurate number at the end. We have the technology now with our calculators and things to keep a lot of decimal places. I keep all my decimal places I can all the way to the end and then round off once at the end to the amount I want. That may not be consistent with scientists and things that do significant digits on everything, but I think we have the ability to keep accuracy now. I like to see that. So I'm only rounding off once here rather than rounding off. I could have rounded off 1, 2, 3, 4 times on the way through. Even longer if I would have calculated this out and rounded off again. So anyway, that's my example of determining the density of the concrete in sample 1-1.